I'm Ryan Roderick, an application engineer for Intersil. In this video, I'm going to demonstrate the ISL28025 demo board that is connected to the ISL9110 buck boost regulator. This is a dongle that converts USB commands to I2C. This is the demo board, ISL28025, that measures current draw from a buck boost regulator. I've started the ISL28025 eval software on a Win 7 system. I also have connected through a USB cable from the computer to the dongle, and is the ISL28025 demo board. To connect to the demo board, press Connect to Device. The software automatically sniffs what's connected to the dongle, and as you can see here is that the software window has it elongated. To the left are the controls for the 28025, and to the right is the controls to the demo software and the 9110 buck boost regulator. Applied to the demo board is a 4-volt external voltage supply. To ensure that the board is powered up, the demo board is powered up through the external voltage supply, the jumper selection has to be chosen such that jumper 1 and 2 are shorted, as opposed to 2 and 3. 2 and 3 will power the demo board from the dongles. And as you can see here, there's no load on the regulator itself, the buck boost regulator, so there's very little current, if not any. And you can see 4 volts is being sourced to the V-bus, or the input of the regulator itself. To turn on the regulator, press the on button. The current sense resistor for this demo board is 50 milliohms. You can calibrate your own sense resistor, or unsolder it and solder your own value of the sense resistor and to change. To do this, to recalibrate your sense resistor, just enter the new ohmic value of the sense resistor and press set res value. The default state once the regulator is powered on is 1 volt. So no load connected to the regulator, so there's very little current. And as you can see, the Vaux pin is measuring the output regulation voltage, which is 1 volt. To set the regulation voltage between 1 and 3.5, to set it, just enter 3.3 into the Vreg out input field, and then press set Vreg. This changes the RG resistor, or the gain resistor, for the buck boost regulator, the ISL9110. By setting Vreg, the RG resistor is a digitally controlled pot, the ISL28025. And once you measure once, you can see 3.3 volts is at the output of the regulator, or the Vaux input. Again, there is no load connected to the buck boost regulator. To add a load, click in the built-in resistive loads circled with my mouse. If you would like to connect your own load, change the jumper position for the output load jumper from 2 to 3 to 1 to 2. That would be shorting 1 to 2. And you can apply a load to the output terminator. I'm going to choose, for this demo, the 68 ohm resistance to be applied to the buck boost regulator. The current is measured at 46.24. This is the current measuring into the buck boost regulator with a 4 volt input. I'm going to lower the voltage being applied to the buck boost regulator such that the buck boost now becomes a boost. And I've lowered it to 2 volts. And as you can see, it's still regulating, the buck boost regulator, and the input is now at 2 volts. And now the buck boost is now just a boost. Now I brought it back up to 4 volts. Now I'm going to apply a heavier load. And when you apply a heavier load, a dialog box or a warning box appears. The warning box is warning you as a user that to make sure that the V-in select jumper is not connected such that the power is coming from the USB port. A USB port can only source 500 milliamps of current. Again, every time you exceed a current threshold that is near the limitations of the USB port, a dialog box will warn you saying make sure that the jumper position is in the correct position. As you can see, I'm sourcing up to almost 700 milliamps of current. The V-bus voltage is measured as 3.915 volts. The power supply is sourcing out 4. There is actually a little bit of a voltage drop due to the amount of current flowing through the jumper cable that connects the power supply to the demo board. Now, there are 3 input threshold detectors connected to the primary shunt of the ISL28025. 2 comparators are connected to V-bus, which measures over voltage and under voltage to the input, and 1 comparator is dedicated to the V shunt channel or the current channel, which measures for overcurrent conditions. We're going to enable the overcurrent detector for this demo, and I'm going to say, well, I want an alert to happen when there is 20 milliamps at threshold range of 40 millivolts. So 0, 0, 2. And what it does is that the dialog box will do is configure a 6-bit DAC such that it has a 20 millivolt threshold, and monitor the V shunt input to make sure that current does not exceed the set voltage. The SMB alert, there are 2 alert pins for the ISL28025. They both share the same digital filter and the same comparators. Again, they're both connected to the V-bus or the primary input, the V-bus and the V-shunt. The SMB alert 2 is a push-pull pin, and the SMB alert 1 is a open drain pin. There's a selection that the user can choose to either monitor the output of the comparator or to signal condition the comparator such that it goes through a glitch filter where a user can choose a minimum glitch of 2 microseconds, 4 microseconds, or 8 microseconds before it passes the signal to a latch bit, which is more or less a D flip-flop. The output of the latch bit can either be masked or unmasked before being sent to the OR gate. The inverter is really the active state of the alert. Is it an active high or is it active low? And for this instance, we're going to enable we're going to unmask the overcurrent, and we're going to put a glitch filter of 4 microseconds. The SMB alert 1 pin is connected to the enable pin of the buck boost regulator, ISL9110. So what happens is if there's an alert that happens, it automatically shuts down the regulator, or the buck boost regulator. And it's just an active feedback without even going through the microcontroller. I have enabled the OC regulator such that it purposely is in an overcurrent condition. And now let's check. It was 34 millivolts, which gave you 686 milliamps of current that the regulator was sourcing, or is being sourced to the regulator. prior to the overcurrent condition. Now let's see if there is an overcurrent condition by measuring once. As you can see here is that you have the backlit is orange, such that it's an overcurrent condition. And you can see that the current draw now is 0, 488 microamps, and everything has been turned off. The Vox is at 0 volts. The ISL28025 has a temperature sensor integrated into the device. To enable that, check the checkbox for chip temp. The ISL28025 buck boost regulator is currently sourcing a heavy load. A heavy load causes, through metal, causes the metal to heat up. Since the ISL28025 is mounted very close to the board itself, it's a good representation of the temperature of the board. And as you can see is that the temperature will continue to rise while the regulator is sourcing a heavy load. Once the load is removed from the regulator, the temperature of the board should go down, as shown currently. This concludes our demonstration. Thank you for watching the ISL28025 demonstration.